Do you want to learn how to create cool automation projects using an Arduino? If you are completely new to Arduino, or even new to programming for that matter, this 20-lesson series of short videos will teach you everything you need to know to get started on your Arduino automation journey. And even if you already have a bit of experience with Arduino, stick around as I will also be covering advanced tips and tricks that can take your Arduino automation project to the next level. You will learn all about Arduino boards, how to program them to read various sensors, and how to use them to control all sorts of devices. So follow me on this journey and let's make some cool projects. As I mentioned before, this is the introduction video to my new Arduino automation playlist. I will be releasing one new video each week for the next 20 weeks, so be sure to hit that subscribe button and turn on notifications if you want to follow this series. And who knows, if this video series does well, I will likely keep making more advanced videos to push your skills even further. In this first video, I will be introducing you to various Arduino boards and describing how they work. I will help you get set up in the Arduino Integrated Development Environment, or IDE, where you can write code or sketches, as we call it within the Arduino community. I will teach you basic programming, including functions, variables, and commands. By the end of this video, you will have written 2 programs and be well on your way. So what is meant by Arduino? Well, Arduino means a couple different things. First of all, Arduino is the name of a company from Italy that decided back around 2005 that they would make an easy-to-use programmable microcontrollers that would be affordable. Arduino can mean physical hardware or breakout boards or accessories that are used to connect different things to the microcontroller. Arduino is also the name of the software, which we call sketches. These are based on the C and C++ programming languages. Arduino also refers to a community of people who love coding and automation so much that they are willing to share their ideas with one another. The Arduino community is considered open source because it allows you free access to the Arduino board design and software that you can use and modify as you see fit. Software is uploaded to Arduino boards to read inputs and control outputs. Inputs can include buttons, sensors, radios, or even your cell phone. Outputs can control things like lights, motors, speakers, and displays. If you can think of something electronic, there's a good chance you can control it in some way with an Arduino. If you can think of something electronic, there is a good chance you can control it in some way with an Arduino. Software code, or sketches as they're called, are developed within the Arduino Integrated Development Environment, or IDE. The IDE allows you to then upload your code through USB cable to the Arduino. Once a sketch is loaded on the Arduino, your computer is no longer needed. Once powered up, the Arduino takes care of the rest. Here's a good example of an output. Here is a good input and output example. If we wanted to control this motor, we could send outputs from the Arduino to control the power and direction. And we could use the motor's encoders as inputs to calculate the current speed, direction, and position of the motor. Here I have just a few of the many different Arduino boards out there. The first one here is probably the most common. It's the Arduino Uno. This particular one is revision 3. This is a great board for prototyping because it has pin headers that can be used over and over. I also like this particular version as it has solder points if I ever want to use it in a permanent application. Next is the Arduino Nano, which is almost identical to the Uno, just in a smaller package. I use this board quite a lot when I need something small. This board only has solder connections, but you can get them with pre-soldered pins and use them in breakout boards like this one. Getting even smaller, we have the Arduino Pro Micro. And smaller still, the Arduino Shao board, which is quickly becoming one of my favorites. Don't let the size fool you, as this board has a processor 4 times as fast as the Uno. This board also has built-in Bluetooth Low Energy or BLE, so you can control it with a cell phone. Last is the ATtiny85 chip that, as you can see, is in fact very tiny. If you only need a few inputs and outputs and need things to be small, this board is a great choice. Let's talk about the Arduino Uno board, starting with the 14 digital pins. These pins can be used as inputs or outputs. As input, they detect either a high or low voltage signal. This can be thought of as a true or false. A typical digital input might be connected to a button or switch. As outputs, these pins can be used to source high or 5 volts, or low as 0 volts, or in other words, on or off. A typical digital output might be connected to a relay to turn something on or off. The pins with the squiggly lines can also be used as variable outputs using pulse width modulation, or PWM. Basically, PWM pins pulse very quickly and produce average voltages anywhere between 0 and 5 volts. A typical application would be something like a motor speed controller or a dimmer circuit for a light. You will also notice that pins 1 and 0 have the TX and RX symbols, meaning transmit and receive. These pins can be used to communicate with other devices such as touchscreens or even other Arduinos. Next, we have the 6 analog input pins. These can be used to measure inputs ranging between 0 and 5 volts, which is a common output for many Arduino sensors. One application for analog inputs would be a joystick, where you want to know the exact position of the stick. There are several ways to power an Arduino. The first way is to use the USB cable that provides 5 volts. You could get power from your computer, for example, and also use the USB cable to communicate with your computer. The second method is to provide between 7 and 20 volts to the jack connection of the Arduino, though most people recommend not going over 12 volts due to heat generated by the voltage regulator on the board. You can either use a battery or a wall outlet with a 2.1 millimeter barrel plug. You can also wire the same voltage using the V-in pin and one of the ground pins. One more method that I sometimes use is to wire 5 volts directly to the 5 volt pin. This method bypasses the board's voltage regulator, so you need to make sure that your supply is exactly 5 volts. You will also see a reset pin in the power section. If you connect this pin to ground, it will have the same effect as pushing the reset button. Now let's download the IDE so that we can get coding. Here on the Arduino home screen, click on Products and then select Arduino IDE. And you will see versions available for Windows, Linux, and Mac. When you open the IDE, it should look something like this. I'm using version 1.8.19. Let me just show you a few tricks here. Under File, go to Preferences. You can change your font size here, make it more legible. Here under Sketch, you have your library manager here. You can see all of these preloaded libraries and your custom ones that you add personally. Here under Tools, you'll see your board manager. You can see that there are quite a few boards that come with it, but using the boards manager, you can add additional boards. For this one, we're going to make sure that we've selected Arduino Uno. So now I'm going to plug my Arduino into the USB cable. And I'm going to go to File, and you'll see here examples. There are several examples that are built in. I'm going to go to Basics and select Blink, which opens up a new code. And what I'm going to do first of all is click here on Tools and make sure that it detected my device. You might have to do this manually, but for me, it's connected to COM3. Now this check mark here is used to verify that there are no errors in the code, so I'm going to go ahead and click on that to show what happens. It will start compiling the sketch. And as you can see, this sketch is very small. It only uses 2% of the memory. but there were no errors, so we can go ahead and click on this arrow button, which is the upload button, to upload a sketch. Now what this code does is it turns on the LED on the Arduino for 1 second and then turns it back off for 1 second. So you will notice here on the board that this light here is blinking on and off once per second. Now that the sketch is uploaded to the Arduino, we don't actually need the USB cable anymore. So I'm going to go ahead and unplug that and plug in this 9-volt battery instead into the barrel jack. And you'll see that the light is still blinking once per second. Let me hold that up a little closer. So as you can see, the Arduino is running completely independent of the computer. Let's go ahead and open a new sketch and talk about some of the fundamentals. First of all, you'll see this void setup. This is a section of code that runs only once, and it runs as soon as the Arduino is first powered on. The void loop, however, is the section of code that runs continuously while it's under power. You can also make your own routines. Here's an example, void subroutine. These loops will only execute when they are called from the main void loop. Here at the top of the code is where we typically declare our variables. So I'm going to paste in a couple different types and discuss them briefly. The first type of variable is the Boolean or bool. And here I have a Boolean called this video is cool, and I have that initialized to be true. This could also be initialized to be false, or a 1 or 0 also mean true and false. The most common type of variable is probably the integer. Here I have integer a is equal to 1, 2, 3, 4. Integers can be whole numbers between -32 and +32,000. If we need longer integers, we can use the long type integer, which can go between -2 billion and +2 billion. If we want some precision and need decimal points, we need to switch types to float. So here I have pi for my example of a float. A character is just a simple character. So here I have my letter is equal to A, and you'll notice that I have those in quotation marks. Now if we want to write a whole word, we would write a character array. So these brackets here would mean an array. So I have an array of characters creating words. Hello world. You'll also notice that every statement is followed by a semicolon. This tells the Arduino that it's time to process the next line. Now let's talk a little about loops. Inside our main void loop, we can put other loops. So if I wanted to do something 10 times, I would write something similar to this. I would have a statement for integer I equals 0, so we'd be initializing the integer I at 0. And while that integer is less than 10, we're going to do whatever is included down here below. And this simply means here that we are going to increment I each time we do it. So the first time it loops, it will be 0, the next time 1, and therefore it will go 10 times. You'll notice that everything here below is enclosed in these curly brackets, and that these sections of the for statement are separated by semicolons. Now, if I only wanted to do something one time based on a condition, I could write something like this. If a is greater than 5, then we're going to do whatever's inside the brackets 1 times. Now we could make this a less than sign, or we could make it a less than equal sign. If you're going to do equal signs, you need double equal signs. So if you want a to be exactly 5, you would write it like this. Now the Arduino can process information very fast, and sometimes we actually need to slow it down. One of the methods to do so is with a delay command. So here are a few delay commands. This first one, delay of 500, this uses milliseconds. So 500 milliseconds would be a half-second delay. The other delay command is delay microseconds, which uses millionths of a second. So a delay microseconds of 12 would mean it would delay for 12 millionths of a second at a time. Now, this method is very easy to use, but is not necessarily the best for all applications. We'll discuss more advanced timing techniques in a later lesson. Now, at the beginning of this video, I promised that by the end you would be able to write 2 sketches on your own. So let's go ahead and get started. Let's hit the File, New, and maximize that one. For this first sketch, we are going to need either a button or switch connected between ground pin and pin 8 on the Arduino. And if you don't have a button or switch, you can actually just jumper across with a piece of wire. Let's start by initializing pin 8 as an input here in the setup loop. So I have this command pin mode 8, input underscore pull up. Make sure you get the capitalization right on these or they will not work. What this does is not only initializes pin 8 as an input, but also initializes it a pull-up, but using the built-in resistor to set it to 5 volts. So when we short this pin to ground, it will go from high to low. Next, we will write our serial begin command so that we can view the state of our pin. So here we have serial.begin and in parentheses 9600, which is the baud rate that we are going to be using to talk between the Arduino and the computer. Now inside the void loop, we're going to add these commands. We're going to have an if statement. If the digital read of pin 8, now what that means is if that is true, we're going to write to our serial monitor with the command serial.println, pin 8 is high, all in quotation marks. Otherwise, if pin 8 is low, we're going to write pin 8 is low. And we don't want to do this too often, so we're going to add our delay command. And let's make it 1,000 milliseconds or 1 millisecond or 1 second delay rather, so that it won't repeat over and over. Now we can check our code with this verify button. I'm just going to hit cancel here because I'm not going to save this. And we see that we have no errors. So let's go ahead and upload this to our board. Once again, I'm just going to hit the cancel button and not save it. All right, now that we've uploaded, let's turn on the serial monitor with this magnifying glass button here. And you'll see it's starting to read. Pin 8 is low. Let me turn on my camera here. You can see I have my Arduino with my switch here, and if I flip my switch, it now says that pin 8 is high. So we've made our very first sketch that detects a digital input. And this sketch might seem pretty simple, but realize there are different types of switches that can be connected to the Arduino. Magnetic switches, laser tripwires, keypads, the list goes on and on. So if you're ready to step it up a notch, let's open a new sketch and go to our next code. Now for the next sketch, you will need a potentiometer. This could be a 5K, 10K, 100K, it doesn't matter. Just connect the outside pins to 5 volts and ground and the center one to analog input 0. Okay, so here above the setup loop, let's initialize our variable potentiometer. And in the setup loop, we will set our pin mode for channel A0 as an input. Don't forget the semicolons. We'll also start the serial monitor at our 9600 baud rate. And down here in the loop, we will read the value from the potentiometer and set it equal to our variable, with potentiometer is equal to the analog read of A0. And then we'll print to our serial monitor, in quotation marks, reading is equal to, and then we'll have a serial.print line, which will add a return after it's done writing, potentiometer. And we will want a little delay maybe quarter second this time, so we can read our readings. Let's go ahead and upload this to our board. All right, now that we're uploaded, let's open the serial monitor. I'll turn my camera back on. As you can see, we're starting to get readings. And as I turn the potentiometer one direction, they go all the way up to 1023. And if I go the other way, all the way down to 0. All right, so we can now read values between 0 and 1023. But those values don't typically mean much. So what if we wanted to, say, convert that to a measurement? Say we had a temperature gauge, for example, that full range was 0 to 100 Celsius. So how would we convert that? So let's write another integer here. We'll call it temperature. And then here we will have our reading, but we'll also add another command to measure our temperature. And we're going to use the map function. We're going to say map of potentiometer, which gives us values between 0 and 1023. And we're going to convert those to be values between 0 and 100. So now here, we're going to change this to serial print instead of line because we're going to add a couple more lines. And what we're going to do here is just copy and paste this to save some time. So we're going to do temperature is equal to temperature. And we'll change this one to print line. So let's go ahead and upload this. I also want to change this delay. It was reading a little fast last time, so let's change that to once every half second. And let's go ahead and upload the sketch. Open our serial monitor. Okay, now we're getting calibrated values. So as I turn the potentiometer, we should get down to 0 degrees. Turn it the other way, get all the way up to 100. So this is a way to scale your measurements on your Arduino analog in commands. Well, congratulations on writing your first 2 sketches in the Arduino IDE. If you've made it this far, I know you're serious about learning Arduino. Now, this was just the introductory video. In lesson 1, we'll jump right in on how to turn on and off various household devices, including lights, fans, and even a shop vac. Stick around. I hope to see you there.